Towards the end of the quiz we had on September 21st, one of the questions talks about a swindler who offers you a game. The game is to choose one of 6 numbers, and if your number is rolled, you win. Otherwise, the swindler wins. Otherwise, you lose. Now, you know those odds aren't good. That means there's a 1/6 chance of winning and a 5/6 chance of losing. So you object. The swindler, being a swindler, offers 3 tries. And the mistake, besides taking it, the mistake is to think that this is about adding choices together. This looks like this is what you're getting. Well, if you have a 1/6 try and a 1/6 try and a 1/6 tries, is that 3/6? Is that 1/2? Because 1/2 would be good. This is a fair game. If it's 1/2, that's like flipping a coin. But well, let's work it out. Now this is tricky, like all good swindles. How many possible outcomes are there? So how many outcomes are there? Well, if you roll a die, 1, 2, 3, 4, 5, 6, there are 6 outcomes. Whoops, I don't know how that snuck in there. 6 outcomes for the first roll. But each of those have 6 outcomes. All right, so there are 6 outcomes under every one of these. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And every one of those, so 6 first outcomes, the first roll. So how about this? First roll, 6 outcomes. Second roll, 36 outcomes. But every one of those outcomes has 6 more possibilities for the third roll. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You know, you get the point. 6 for every little branch there. So by the third roll, there are 6 cubed, or 216 outcomes. Now, why is that important? Well, if there are 216 things that can happen, that's your sample space. So your sample space has 216 outcomes. How many involve a 1? Because those are the times you're going to win. So examples, 1, 1, 1, 3, 1, 2, 6, 2, 1, 4, 5, 1, and so on. There are clearly lots of ways of rolling a die 3 times and getting a 1. How do we find all of them? Let's go back to our diagram. If you rolled a 1, so first roll, or 2, or 3, or 4, or 5, or 6. If you roll 1 and you keep rolling, there are 36 ways to roll. Oh, sorry. a die 3 times, starting with a 1. So there are 36 ways. You can have 1111, 1112, 1113, 1114. Try listing them out. There are lots of ways. It's every possible way of rolling 2 dice with a 1 first. So that's 36. Now what happens if you roll 2 first instead? Well, after you roll a 2, you could then roll a 1. Or you could roll a 2, or you could roll a 3, or you could roll a 4, or you could roll a 5, or you could roll a 6. Now if you roll a 2 and then a 1, well great, you're going to win, and there are 6 ways that can happen. So I'll try to squeeze those in here. You could roll 2, 1, 1, 2, 1, 2, 2, 1, 3, 2, 1, 4, 2, 1, 5, 2, 1, 6. 6 ways of rolling a 1 after rolling a 2. If you roll a 2 and then you roll a 2, the only way you have to win now is if you roll a 1 on your 3rd roll. That's it. If you roll a 2 and then you roll a 3, the only way you can win is to roll a 1. If you roll a 2 and then the 4, the only way you can win is to roll a 1. If you roll a 2 and then the 5, the only way to win is to roll a 1. If you roll a 2 and then you roll a 6, the only way to win is to roll a 1. So if you roll a 2 first, there are 11 ways of winning, even if your first roll is a 2. And nothing about this dependent on it being a 2. If you roll a 3 first, then you could roll a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You could roll a 3, then a 2, then a 1, and a 3, and a 3, and a 1, and a 3, and a 4, and a 1, and a 3, and a 4. The idea is not to count these again, but to realize that the 11 ways of winning, if you roll something else on your first roll, is the same for these other numbers. So you're going to have a total of 36 ways of winning if you roll a 1 first, plus 11 ways of winning if you roll a 2 first, and 11 ways of winning if you roll a 3, 11 ways of winning if you roll a 4, 11 ways of winning if you roll a 5, and 11 ways of winning if you roll a 6 first. For a grand total, that's 55. There are 91 ways of winning. So that means the odds are 91 over 216 possible outcomes, which is about 42%. What makes this game tricky is that 42% is only a little bit less than 50%. Remember the mistake earlier. The mistake is to add the probabilities to get half. Half is a fair game. 42% of 216 outcomes is hard to wrap your head around. And it's actually hard to do with an experiment. A little earlier, I shot a few videos and people showed up and interrupted me. Here's a set of 10 that I was doing for one of the videos. And there were 6 wins out of 10 and 4 out of 10. That sounds pretty good. That sounds like 60%. The second time I tried shooting this video, I got 50-50. I got 5 out of 10 wins and 5 out of 10 losses. So that still sounds pretty good. At one point, I had a bit more time, and I did 40 trials. You can't see them all. But 40 trials gave me 16 wins out of 40, which was 40%. It's starting to get close to the theoretical. Doing it this way gives me an experimental probability instead of a theoretical probability. And the thing to note here is that depending on, it's not unusual to end up with clusters. These last 10 experiments, it's 50-50 win-lose. If you look down here, starting here, if I count this as the first try, if I do 10 more tries, continuing up here, I'll end up with 7 out of 10. So when you're rolling a die, you could roll a die 10 times and get a percentage of wins much higher than 40%. Or you get lower than 40%. I wonder what the lowest run here is. Let's see. Just hypothetically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first 10 give you 30% wins. That's less. I don't know if there's anything worse than that. But this is the difficult thing. Just like when we rolled the dice in class, and I showed you a graph of the ideal distribution and then a graph of the 400 trials that you collectively did, the graphs didn't look the same. It takes a while before experimental data meets theoretical predictions. So even though the game is not fair, it's biased towards the swindler, you could still play 10 times and come out ahead. Casinos bet on this happening. Every game in a casino is stacked against you, but people will come out ahead. And these people are great. They advertise. They had a great time. They had good luck. That's what they say. And they tell you how good the casino was, and you go. But maybe you have this experience. And when you average those two together, you get 50%. And the more of these trials you do, the closer you get to the actual game, the actual run. All right, so that's a really long-winded explanation.